Lesson 2 is about factorials. So factorial is a new thing that you will be learning, and it's kind of fun because it's actually represented by an exclamation mark. So now you could think we're getting really excited about math, but in fact, we're just doing more math. So if we see an exclamation mark, it means a specific thing, and we'll get to that on the next slide. For that, let's try the warm-up. A league consists of 4 teams, and how many ways can they finish in the league standing? So I'm going to use fundamental counting principle, and I know that someone needs to place first, someone needs to place second, someone's third, and someone is fourth. So how many of the teams out of the 4 could place first? Well, potentially any single one of them could place first, so there are 4 options. Now for the second place, we know that somebody has already won first place, so there's only 3 teams that could win second. Same as for third, now we only have 2 teams left, and then fourth place, only 1 that hasn't been placed, that has to be in fourth place. So it's 4 times 3 times 2. 4 times 3 is 12, 12 times 2 is 24. So 24 different ways that they can place in the league. Okay, and in how many ways can the letters from the word smile be arranged? So first off, I have 5 different letters here. And it says be arranged. That means that I can't have any repetition. So there are 5 different options for the first letter. Then we go down to 4 because we've used one up. Then we use another one, and another one, and another one. And we're left with 5 times 4, which is 20. 20 times 3, which is 60, times 2 is 120. Okay, and number 3, in how many ways can 6 people line up at the bookstore? So there's 6 different spots closest to the counter. There's 6 different options for who can go in the first spot. After that, there's 5, then 4, then 3, then 2, then 1. So 6 times 5 times 4 times 3 times 2 times 1 is 720. So there's 720 different ways. So here's where factorials come into play. If I look at all of these examples, every single one of them starts at a number and then goes down all the way to 1. So the first one, we have 4 times 3 times 2 times 1. Then the next one, we have 5 times 4 times 3 times 2 times 1. Then the next one, we have 6 times 5 times 4 times 3 times 2 times 1. So this one here can actually be written as 4 factorial. It means we take 4 and we multiply it by every number lower than itself all the way to 1. That makes this one in the middle here 5 factorial, and the last one is 6 factorial. So you might think, well, why is this necessary if I can just multiply those things together? But if we get to big numbers, even 11 times 10 times 9 times 8, it takes a while to type in our calculator, whereas our calculator actually has a button for it. So let's go through that. It says when all the members of a set are being arranged with no repetition, the number of arrangements can be represented by factorial. So here we have 10 times 9 times 8 times 7 all the way down to 1. Okay, that is equal to 10 factorial. And then here it says try it on your calculator. So I want you to go ahead and do this. Type in 10, then press your math button, then over, and then press 4 and enter. You'll see the exclamation mark and you can actually type it right in on your calculator and it will give you your answer. So now the only thing we have to talk about is what happens when we don't have a number but just a variable. So n factorial is read as n factorial. That means that we take n and we multiply it by the numbers less than itself all the way down to 1. Notice that you can't have any negative numbers here because we only go down to 1. So let's try some examples. Use your calculator to determine the value of 5 factorial. So we already did that on the first page, but we can do it again. Use it 5 times 4 times 3 times 2 times 1 is 120. Okay, 12 factorial. Type that in on your calculator. Oh, it's a big number. 479,001,600. If I did it on my calculator right. I don't have the factorial button. Holy, the next one's going to be even bigger. Let's see if my calculator will do it. So I'm going to take the 12 factorial that I just got from the last question, and I'm going to multiply it by 6 times 5 times 4 times 3 times 2. Oh, it converted into scientific notation. So I got 3.4 times 10 to the power of 11. So hopefully your calculator gave you a more precise answer. If not, that's fine. You can write down mine. All right, next one, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 3 times 2. Make sure that you're using the factorial button on your calculator. Is 241,920. All right, next one, we have 9 factorial, which is 362,880 divided by 3 factorial, which is just 6. Okay, and that brings us to an answer of 181,440. So these are just a matter of typing them into your calculator. They're not too tricky. But now let's go the opposite way. So now we're given the factorial, or we're given the expression and we have to write it as a factorial. So the first one, we have 9 factorial, and it goes all the way to 1. Next one, we have 5, and it goes all the way to 1, so it's 5 factorial. This one here is a little bit trickier. I have 8 times 7 times 6, so it's really tempted to just say that's 8 factorial. However, 8 factorial would go all the way to 1, and we stop at 6. So how are we going to solve that? So if I have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and I want just the 8 times 7 times 6, then I somehow need to cross out the 5 times 4 times 3 times 2 times 1. So if I was able to put a 5 times 4 times 3 times 2 times 1 on the bottom of my fraction, I could then actually take those and cancel them out and be left with 8 times 7 times 6. So in order to do that, I actually have 5 factorial on the bottom. So this one here is equal to 8 factorial divided by 5 factorial. So we can use that same type of thinking to answer the next question. We have 10 factorial, but then we stop at 6. So that means we need to divide out 5 factorial, and you can write out the steps like I did above if you would like. And then always, always, always check it on your calculator to make sure it's right. You can type those in separately and make sure you get the right answers. All right, we are on our last slide, example 3. In how many ways can the letters of the word champ be arranged? So normally what we would do is we would write out our different options. So there's 5 different letters, so you'd write out 5 different lines, and then you'd say, how many options do I have for the first one? How many options do I have for the second one? But since we know that they are distinguishable items, we can actually just express that now as 5 factorial. Okay, type in 5 factorial on your calculator. We've done that quite a few times. And that's equal to 120 different ways. In how many ways can 10 people line up? Same idea, that's going to be 10 factorial. You can type that in on your calculator. And how many different ways can a team of 8 players sit on a bench? 8 factorial, you got it. And how many ways can 6 people sit in a row? 6 factorial. So make sure that you actually type those into your calculator and find out the possibilities and write the answers down. All right, so now for some practice. Get lesson 2 factorials worksheet from me and then work on page 81, numbers 1 to 5, 7 to 10, 12 to 16.